So welcome back to another version of ARCA's Elevated Views. Today I'm sitting down with Stephen Epp, the app project engineer. Welcome, Stephen, your second appearance on our podcast. Thank you very much for coming back.
Thanks for having me back, Kevin.
Today I'd like to talk about the life cycle of a roof. And this is following an article I know that you published a little while ago. And it was very unique because you equated the life cycle of the roof to a cake, and the icing on the cake being the membranes. For those just listening, can you give an explanation of how you describe the roof as a cake?
With all the components of the roof, I tend to think of it like a layered cake that you'd get from a deli or grocery store that would have the icing on the top is the waterproofing component. The insulation is the nice inside of the cake, the chocolatey bit, and then the plate on the bottom is the structure. So depending on how many layers of the cake that you've got, you can build up those components. And I find the analogy works really well when talking about the roof systems. Sometimes when people are saying, I need to replace my roof, maybe you just need to take off the waterproofing component, and that relates just to the icing. Maybe you can leave the nice, soft, squishy inside of the cake if it's in good condition. And then sometimes you have to replace it all the way down to the deck or to the plate and rebuild that whole cake all the way up. You can kind of visualize it in your mind, the layers of the cake with the layers of the moisture barrier, the insulation, the vapor barriers, the underlays, all these different components of the roof kind of correlate to the cake itself, which is kind of a fun analogy. Everybody knows cake.
And I think it's great because then people can also, I even say in the professional community still, there's still a lot of people who don't understand that conventionally insulated roof, and they don't understand all the layers. So describing it that way, it's a unique way, and I think it's a fantastic way to describe it, especially when we're talking about roof replacement. A lot of people think roof replacement, I need a whole new cake, and maybe I might even need a new plate because maybe there's something wrong with the deck. But it allows you to describe some of the different possibilities of providing extended life to that roof. Is that a good way you can describe that analogy?
Absolutely.
Either re-roofing or membrane replacement, those type of things?
Yes, it's a really good way to do it because you could just scrape off the icing and replace the icing on the cake. And that would be just replacing the waterproofing component and leaving in the others. I like the plate discussion because if you consider if the cake were to get wet and soggy and was a paper plate that you were holding your piece of cake on, moisture in the cake seeps into that plate. Right? You've all been to a picnic on the outside and you're holding this paper plate, and whatever you've got on the paper plate has been sitting there long enough that the plate is now starting to bend, starting to fold, and you're very concerned, so you start to eat even quicker. Right? If the plate is no longer supporting the system, then you would throw out your plate and go get a new plate and a whole new piece of cake, right? It's the same with the roof system. If you have water sitting in your system, the insulation is wet and it is seeped down into the deck component, whether that's a steel deck or a plywood, like a wood deck. If the deck itself has been compromised, you have to throw away the deck to build your new assembly on. So again, with the cake system, it works pretty well. And everybody has immediately a picture of standing in a field with holding onto a soggy, cheap paper plate with some food on it.
I believe becoming more apparent with the movement to produce less waste. Sometimes that's all you need is a new membrane.
Absolutely.
And then you can extend the life. Does it always have to be the same type of icing that goes on?
It really depends on what's there and kind of what the system is. But if you're right, if you don't need to throw out these components and they're in good shape, even after 20 years, 25 years, the insulation layer is still in good condition. There's no need to throw it out. You could just leave it in, so taking off that top piece and just replacing that. Your cost is way less. The price will be way less. There's less demolition, less time on site. Like, it's a much more clean in and out for pricing. You may not get a full 25 or 30 years out of it that you would expect if you did a full replacement, but you can get a warranty for 10 years, 15 years is pretty standard. So that's not out of the question to bump things along for 10 years rather than having to replace the whole thing and cost you an arm and a leg. And we don't want to throw out material that's functioning well. If we don't need to, we're trying to come up with a clever way to leave it in. What the system is there will kind of drive what type of icing or membrane you can put on top of that, and that includes like how it's attached, the type of material itself. You have to see what you have versus to what you can put back on.
So I've had some technical calls as well too, and I know we don't allow it with our standards, but some people do phone and say, well, can't I just put new icing? Can't I just put a new waterproofing membrane over top of one that's, maybe it's leaked a little bit, but can't we just cover that all up? What would be the dangers in that?
So the danger of covering something up is that if the water is now in the system, potentially compromising the new icing that you're putting over top of it, that water will continue to freeze and thaw and will off-gas and will create blisters, and then it'll compromise your new system that you've put on there. You don't want to be putting something over top of it. So typically in that scenario, if you had a huge roof and say 5% of it was wet, you would just cut out those sections of it, replace those fully, and then the rest of the roof, the other 95% of it, you could just do a coating sort of a system or recapping over top of it. Coatings themselves can be kind of finicky, and there's a lot of surface prep specifics to each roof before you can do that. But you don't want to leave in compromised material. You want to get rid of that.
And another thing that you mentioned in the article, which is, I think, very important because a lot of people with the new National Energy Code that came out and with reduced energy costs, you can also add layers to your cake if you do take that icing off.
Absolutely, yes. If you have a roof that was designed, let's say it's 20 years old, in the early 2000s or something like that, the code would be different for energy. So you may have thinner insulation and you want to increase the thermal performance of your building. You can add insulation on top, so you can screw it down or glue it down to the existing and leave those existing components in. Adding another layer of cake, your old cake, you can certainly do that to improve the thermal performance of the roof.
Now, do you have to do that to meet the new energy code?
In re-roofing, you're not required to meet the code, air quotes on the code. You have a series of the National Energy Code, which is based off the National Building Code, Alberta edition here. So, but if you're in the re-roofing world, you're not required to meet any sort of levels. So it's in the new build world is different than a re-roofing world. So it comes down to a lot of the owner and the kind of the client's needs. They'll often see increasing the insulation on your roof can correlate to a better energy efficiency, or they're trying to hit a certain target for their building by doing retrofits and things like that. They can come to us and say, we want to replace our roof. We need to hit our whatever they need to do, and then we can build from there and try and leave in what they have and add on to what they've already got. So it comes down to a lot of client wants or budgetary constraints and things like that.
So what other types of improvements can you do with just a membrane replacement? Say we've touched on the one that you could add the additional insulation, but what other kind of situations can you do to help that roof reach a higher life expectancy?
Sure. The big one is adding slope. So you can add sloped insulation, you can add drains. If there is a large roof area with only a single drain, plumbing code has certain criteria that you're trying to achieve as well, but typically if there's not enough drains and you end up with standing water on the roof, that will limit the life cycle of that roof system. So if you can add drains and build up a slope package on the roof to direct the water to the new drains, that's something that you can do in as well. Sort of in the cake analogy, you'd be leaving in the bottom layer of cake, and then you'd add a sloped piece of cake on the top, on top of the existing one, so that the icing is sloped nicely. There are some caveats that you need to deal with on that one, with the structural being able to handle ponding water loads and things like that, but that's another opportunity, is the sloped insulation.
So just getting into the technical aspects of that, you touched on the structural aspects. Why would you need to get a structural review done? Like say you're going from a 1% slope to a 4% slope on the roof. Why would you want to get a structural analysis done of that roof?
I think the best way I think about this is having a pyramid, flip it upside down, and your drain is right at the point of the pyramid. So now you have an upside down pyramid drain at the bottom. If you have a flat pyramid, very low, that's the 1% slope, the water would only need to fill up not very high before it would spill over the edges of your upside down pyramid. If you have a 4% slope that's quite steep, the pyramid takes a lot more water to fill up before it would spill over the sides of it. So the amount of load on the roof deck, if that drain were to plug, can become quite a bit more. So if you had an existing roof that was flat, if the drains plugged, the water would just kind of flow and distribute out nicely. The more slope you get, the more concentrated that load becomes. So you can't always just put slope package on and build up without putting emergency overflows and things like that to have water being able to spill out. Again, it's very site specific. What we would look at for a wood frame building versus a concrete frame building versus a steel deck and a warehouse, right? These are all sorts of something that you would take into account when you're doing that preliminary design. Oftentimes warehouses with long span open web steel joist and steel deck are built exactly to the load criteria, so adding load is a no, where a concrete building typically has more capacity built into it that you can play around with a little bit more. Again, very site specific.
So even if you don't increase the slope, do you also have to get structural engineer to look at it if you're increasing the insulation? So say if you have 4 inches of insulation, say 4 inches of polyiso, you're adding another 4, maybe 6 inches of polyiso to that. Would that require that structural analysis, or it's kind of negligible?
Negligible at that point. The weight of the insulation is relatively light, and oftentimes you're taking off a built-up roof system. You're skinning off something that has gravel or asphalt in it that has weight in it, and modern roofing assemblies are lighter than what an old hot asphalt and gravel system would be. So by taking off the icing, that could be very heavy icing, and replacing it, you get a bit of an allowance to play with. Typically, we wouldn't look too much into that.
So you're taking off the fondant and you're just putting on the butter icing.
There we go.
So it looks a little bit better. How about for the drainage as well too? So if you just have one drain, say a 3-inch drain, and I know this is very site specific, but in the middle of your roof area, and you increase that slope from 1% to 4%, should you be looking at that drain size and the drainage design as well too?
The way that you calculate the drain is just by projected roof area. The water should flow to that drain regardless of the slope is 1% or 4%, but you certainly don't want to enlarge the catchment area than what that drain was originally intended for. Oftentimes we're adding drains in retrofit systems, so the drains will seed less than what they were previously, but it's worth looking at. You can do rain load calculations for the 15-minute rainfall in Calgary and see if a 3-inch diameter works. We have some clients requesting, can we project out into the future? We think there's going to be more rain loads. What would it look like if we had an increase in like a microburst storm in Calgary, and let's put together a heavier rain load in a 15-minute? What does that look like to our drains? And then we can do the numbers and say, okay, well, if you want that sort of a future, you should increase it to a 4-inch diameter. But that has a whole bunch of, pardon the pun, downstream effects of the internal leaders and then into how the stormwater is dealt with, and that gets more into the mechanical engineering side. There's no code requirement to look at that, but you certainly wouldn't want to retrofit your roof and then overload your drain accidentally, and then you have a crazy storm and then the pipe backs up. It's something that needs to be considered. Typically when we do these sorts of conversations with the client, we'll have a sort of a checklist of what do you want to do with this? What do you want to do with that? How do you want to approach this? This is your limiting heights. This is what you're dealing with. What would you like to eat?
Yeah. So what type of things would limit how high you go on, say, on the insulation or on your slope package? What kind of questions are you concerned about, or what kind of site-specific items are you concerned about when you're looking at that kind of design?
Sure. I think they fall into three nice categories. One is door thresholds, so roof access doors, anywhere that there's a door that you wouldn't want the door to become your overflow if the drains were to become plugged. So by increasing the insulation thickness, you don't want to make it flush with the door threshold. Parapets, so what's going around the outside perimeter, or if there's a interior penthouse or something like that, you have to think about what the upturn height you're trying to achieve on the parapets. And then the other one is mechanical units or mechanical equipment. So if there's a humongous mechanical unit on the roof that's already low, by increasing the insulation, you now need to lift the unit and maybe put a new curb underneath it, or you have mechanical vents coming out, ducting, things like that, that are low, that would become buried or would get really close to the roof. And then you're starting to talk about, if I do this to the roof, then I also need to do this to the mechanical systems. I had an interesting one downtown where they wanted to add insulation and their tie-back anchors were really low already. We buried them. For their criteria, they were more interested in the thermal performance, and they said, okay, that's fine. There was only a couple tiebacks, so we just designed them a taller tieback, a pedestal post, and just included that with the roof package. They were more wanting to achieve a thermal value than concerned with 4 or 5 tiebacks. So for that client, it was very specific, but by adding insulation, we buried things on their roof that we needed to then deal with. So,
and that's probably one of the services that you guys provide is similar to that checklist. Well, you can have this, but then these are the ramifications. And then it's really client-driven, what they'd like to do and ultimately how much they are willing to spend.
It's a very budget-driven discussion. And our report will often say, here's the issue. We'll put a picture in. Here's where your door is really low. Would you like to A, B, or whatever? And then depending on what they want to do, we can get costing involved or go get a contractor to say, how much would it cost to raise the whole door up, like reframe a door? We're just presenting the information for them to make an informed decision. It typically comes down to how much is that going to cost?
What are you seeing the trend going towards? Because the life cycle of a roof, I always say it's out of sight, out of mind. A lot of people don't pay attention to it. Mm-hmm. But then the other pun is 5% of your problems come from 95% of what you see. So if you don't see the roof, you're going to see the problem at the end. So do you see the industry going towards more skinning or membrane replacement or full replacements? How do you see that going in, say, the next 5 years?
We're seeing an increase in requests for how do we do this to lower the pricing. The cost of roofing has gone up an astronomical amount in the last 5 years, 4 years, right? With COVID, the supply chain issues, labor pricing, like everything is up. So now the roof that maybe used to cost 100 grand is now double, right, at 200 or something. And the owner is saying, holy, they hadn't thought too much about the roof system, and then all of a sudden it's leaking, and they're saying, this is $1 million for me to replace this thing? Like, holy smokes, I didn't really understand that. How can we make this cheaper is often how that question starts. Like,
okay.
How can we better use our funds? Because we've only allocated this much from our 5-year budget that we did in 2019. We used 2019 dollars and wasn't projected to be this much. So then the conversation is, well, okay, let's talk about skinning, right? Is this an option for your roof? And then we'll do our series of tests, cut tests and moisture scanning. We can do wind uplift tests and all sorts of things to see if it is a good candidate for it. And then we will present them with options from there. Our kind of argument is, yes, you'll spend a little bit on consulting up front, but you could save hundreds of thousands of dollars if this little bit of costing and testing done. There's a pretty big payoff if we can give it the green light to do a reskin. It's becoming quite a common question. It's a good question. I'd have the same question if you're replacing your roof on your house. Like, what are our options? Like, this is very expensive. How do we deal with this? Like, is this a valid cost? I think it's a good question. I appreciate the question. The owners are thinking about, how do we deal with this?
So just touching on some of the tests that you do, you're evaluating some of the possibilities. Why would you want to do a cut test? We'll just start with the cut test. What does that give you, and what does that provide the owner with providing those cut tests?
So we'll get a contractor to come out with us. We'll start with asking the client, do you have a history of leaks here? Where is it leaking? How is it functioning? Things like that. And they'll often direct us to, okay, we know there's an issue here. So then that'll give us a good starting point. And then what we'll do is often walk around the roof with some sort of a moisture meter, like a handheld Tramex scanner or something like that. We can use infrared and do thermal imaging and try and figure out how much water essentially is in the roof system. And we need to validate these handheld scanners with a cut test. So we'll get the contractor to cut us a 1 square foot core. That will validate our moisture meter, and then we can use that to extrapolate across the rest of the roof. And then we'll get a map of how much water is kind of in the roof. It'll also tell us from the cut tests what the layers of your cake are. What type of cake do you have? You got a Black Forest cake? You got a birthday cake? What kind of cake?
And if water gets in there, sometimes it doesn't go all the way down to the deck. Maybe it's only into the first layer of insulation, or maybe it's through the insulation to the vapor retarder, but then the vapor retarder has done its job and it's stopped 99% of the moisture there, and it hasn't gone down past that.
So we'll do a series of cut tests around the roof and kind of get an understanding of what the existing condition is to tell us what are we dealing with here. We had an interesting one recently where the original question was, we'd like to recap, so putting a new SBS cap sheet over existing. And we went out to site and started to poke around. Huge amount of the roof had water in it, in these little pockets everywhere, where there had been blisters, the seams had previously ripped, and water had gone in and spread into a few square meter areas. It was all over the place. And so we said, you could go and cut each little section out and replace that and then skin over the whole thing, but we call it quilting it. You lose any economy of scale, like you're just doing all these little individual repairs. And we said the recommendation is to replace the whole thing, because at some point it doesn't make sense to try and just scab together a whole bunch of little repairs. You're going to end up with like a 10-year roof versus just redo the whole thing. You'll get a 25, 30-year roof. Yes, it's going to cost you more, but at some point the numbers don't really line up. They had asked, can we just recap this? And we said, we don't recommend that.
Well, I only have a certain amount in my maintenance budget. I'm going to do X amount of repairs, and they'll do that for 3 or 4 years in a row. But really, if you add up those 4-year repair costs that they've done, it would equal what it could be a whole full replacement of it.
Yeah, some of the areas, when we start to get into larger areas of replacement for wet components, it can get pretty pricey, because you're not dealing with production crews anymore, you're dealing with service crews. You're paying by the hour and on a time and material rate, whereas production full replacement, you're getting a crew that is a well-oiled machine that can bang out a huge roof area. So you get a much better price on a larger area than paying the repairman to come in.
Well, yeah, because those patch and repair crews, they're usually 2 to 3 people.
Yeah.
Right, where the production crew, like you say, it's that 6 to 7 person crew. Everybody has that task. Everybody knows exactly what they're doing, and to rip and replace.
Yeah, and then there's nothing worse with the client pays for a whole bunch of patch repairs, and then it just keeps leaking because the rest of the roof continues to fail.
The other test that you commented on there was uplift tests. You require uplift tests on membrane roofs for new construction, but do you find people are asking what the uplift is for existing roofs when you're looking at either a membrane replacement or a full replacement?
The question doesn't normally come up from the client. It's something that we do. I think it's a good idea. There's nothing that says it's required. There's nothing in the codes or sort of anything that says you have to do this. If you're just going to replace the icing on the cake, or maybe the first couple inches of the cake layer and leaving the rest and the plate and everything else in. I want to make sure that the pieces that you're left in are actually stuck down to the plate. There's not very often you see a wind blow off event happening. Like, it's a relatively low risk, but you are taking off something that's potentially heavier and putting on something that's lighter. So you're changing how this works, and we do like to validate that the system is attached and it would meet a current test. So we do check and see what the wind uplift would be for a new build in that same area, in that same sort of the height of the building, the size of the building and all that. We do those numbers, and then we'll go and do hole test on site, and you're gluing down a piece of plywood and pulling up on it and seeing how well the system's bonded. It seems to be either it's extremely well bonded and we stop the test because it doesn't fail, or as soon as you cut into the roof, you can just pop it off.
It fails right away.
It's either one or the other. We don't often see these kind of middle of the road ones.
Okay.
So we're still kind of going through the process here. So every time we do one of these, we just collecting data. If the roof is well bonded, then you can attach your new icing onto the existing roof. No issues there, using a glue or a hot asphalt or something along those lines. If it isn't, depending on the deck, wood or steel deck, we can put mechanical fasteners through it, pin it down, and then glue on a new system on top of that. So there's two ways to do that. Or if you have a concrete deck and it isn't adhered. But sometimes when we do these tests, only a certain component is not attached. Like the insulation will fail between layers of insulation and it'll remain stuck down at the bottom. So then that says, okay, well, let's just skin at this layer. We'll set the saw height to take off this much and leave the portion that's stuck in. And so there's various combinations you can do that with.
Perfect. Well, I've loved talking about cake. I know my favorite is a 5-layer German cake, so I like a lot of insulation. As you can tell, I have a good layer of insulation on me, so it works well. So thank you very much. Is there any kind of items or comments that you think we missed when we were talking about the life cycle?
No, it's good. I think it's an interesting conversation, and I think just having that analogy for owners to understand, even if it is a full replacement, they can understand this is what we're talking about here, and I think it's a nice kind of fun way to describe
Absolutely.
it. So.
Everybody can relate to food, or you can relate to cars, right? Those are the two things
You bet.
everybody can relate to.
Nope, I appreciate the opportunity.
Perfect. Well, thanks, Stephen. I hope you have a great rest of the day.
You too. Thanks, Kevin.
Thanks. Thank you for listening to another episode of ARCA's Elevated Views. We hope you have enjoyed the program. For additional information on ARCA, our contractors, or our program, please go to arcaonline.ca. Or you could follow us on Instagram at Roofing Careers or on LinkedIn at ARCA-Alberta Roofing Contractors Association. Thanks and have a great day.